pages for today. I got a couple of bounce backs saying that you had a 20 megabyte limit instead of 25. So some people may not have received the pages that I sent through, but we could always put them into the drive location so everyone has access. I sent around every page for A1 to A3, even geothermal, because they're all completed, signed off by CLF. So everyone now has all pages with all updates. So cast iron has been added in, we added in carbon steel. Let's see. There's a bit of modification on the ductwork and piping calcs for Revit. So it should be good on that front. Did anyone have thoughts or questions on the material that's been shared? Okay, cool. So in let me open up the presentation. All right. So today we've got fixtures as our topic. Number of different things to cover here. Let me slideshow mode. So this is the second to last session that we'll be having. So we've got fixtures this week with lighting, PV, plumbing fixtures, and vertical transportation. Q&A for that will be next week. We're going to skip a week and then have spring break for my child, so I'll be off that week. And then the week after, we're going to do geothermal. So we'll do that with the Q&A, assuming not many people have geothermal projects. Always good to know, though, in that space in terms of how to measure it when you do have those systems on your project. And then after that, we'll be moving into A4 through C, so covering a couple of life cycle stages per week. And those, we can take a group vote on that. I'm actually going to post something in the chat right now of whether or not we want to keep that kind of Q&A week open, or maybe do Q&A every couple of weeks, because it does seem like the Q&A has been a little light. I'm going to do a keep Q&A session post and then get rid of Q&A sessions. If you want to like either one of those, we can decide how to proceed with having that kind of off week in between. Kim?
I'm kind of going to lobby a little bit for keeping the Q&A weeks open, because I get a feeling, and I'm not going to name any names, but their initials are TLC, has been a little bit behind, and we may not be the only ones. And once we get into it, it might be helpful if the Q&A was able to go back and cover some stuff that was covered in not just the immediately previous week, but maybe months ago. Like I said, not casting aspersions on anyone. It's just that maybe that might be helpful. So just putting that out there. Don't yet, no shame, no recriminations, no askance looks. So if that's something you're interested, vote for the keep the Q&As.
Everyone's voting to keep the Q&As, it seems, so far. So not just TLC, I think. Another thing that we can do is, now that everyone's had a chance to work through some of those scheduling bits on their own, and we discovered a lot of really great information, is we could maybe share a Revit test project file with everyone with all those schedules in there. So you just insert from file on your own projects, which seems like that would save everyone a whole lot of time. So add another task for myself on being able to do that, but I think it's a good idea since it's not that much work. Share it on the drive. Hopefully that is exciting to everyone, because I've imported them from different projects now, and they seem to be working great in between now that we've worked through some of the kinks. So go back to sharing the PowerPoint. All right. So the agenda for today, like I said, we've got several different portions to go through today, starting off with light fixtures. We're going to cover PV panels, vertical transportation, and then plumbing fixtures. You've got the individual pages. Those each have all of the steps around visual review and creating schedules in Revit. And when we were actually going through them with CLF, they were like, do you need to actually have these as separate steps for every category? And we do, because they're different enough in terms of the way that they function, that the formulas are different, the objects you're looking at are totally different, the types might be different. So kind of having those disparate directions seems to be necessary on each section. So we're going to start by going through light fixtures first. I do have a model opening up in the background here. I'm not sure, did Alfred join us today? No, it didn't look like he was able to join. So Alfred initially did the takeoff portion for Weimer Hall on our case study. But for lighting, the designs could be done by one party, multiple parties. It could be the lighting designer is in-house for you as an electrical engineer. Maybe you just did the back of house lighting. The architect may have a lighting designer. Your engineering firm may have a lighting designer. The lighting consultant may be totally separate and doing their own modeling exercise. So making sure you know first who is doing that design and what portion they're doing is really important, so you know where to find the modeled objects. And hopefully, fingers crossed, they're not in CAD. You're going to be doing a lot of manual quantity takeoffs. But knowing who designed it, what model it's in, is the first step there. Similar to the other scopes we've gone through, you want to first do a quick visual check. So just going to visibility graphics, doing VV for a shortcut, isolating just the lighting fixtures category. So you're just seeing all of those lighting fixtures in the background. And then figuring out what the relevant parameters are. How did they label the light fixtures? Your electrical engineer will have a really good idea of what that looks like, because they're the ones who have to circuit them up. So they should know kind of, they put their type name over here, HL1, and then the wattage sits over here. So they'll probably know better than you would right away kind of what that looks like in the model. And then once you've got a rough idea of how many lights you're dealing with, how many different fixture types you have, you'll want to create a schedule of those light fixtures. So we would go to view, schedules. I'll do this live. Select lighting fixtures. I'm actually just briefing myself now. And then putting in some of those fields that matter. Kim? You're muted.
Want to switch to the Revit view?
Yes. I'm reading it so I remember what to do in Revit, and I'm doing it for all of you too. Then you would get the family name. Oh, and then the count parameter. Rachel went through that during mechanical equipment. Really nice feature. So you can just get the number against the different types. And then itemizing every instance is really key. And then you're able to gather the quantity of each type of fixture and find the right EPD to pair that with. So let me make sure my Revit screen is functional. I'm going to share what that lighting schedule looks like with all of you. All right. So on this project, I created a light fixture schedule after looking at the lights in 3D. So let me also do that for you. So if everyone doesn't remember, you go to view and then 3D view. And then those are plumbing fixtures. I'm skipping ahead here. You want to do all. And then light fixtures here. All right, so we've got lots of different lights in the background. You can even just do a quick swipe of them. Look at the little funnel in the bottom to see how many you have. 1,021 lights. That's a whole lot of light fixtures. Then you come over here to that schedule. So to create the schedule, you can go to view at the top. Sorry, this little bar is getting in the way. View, and then schedules and quantities. And then you would create a new schedule under there. Now, under the schedule, I decided that a couple of different parameters mattered, the family and type, and then the family. They're pretty close to each other, but the family and type has that little appendage name in it. And then that count property is also really key here. So just got family type, family, count, and then filter comments as well. I found that some of these fixtures actually did not have their length associated with them when they were linears, right? Even if some of these were, let's say, 4-foot linears, some of them were kind of bespoke sizes, and I had to find a median size to try to get the right balance in there. So I've added in this additional parameter. I called it length, but put it in filter comments. It might be hiding in another property in your model. So we can just take a look at some of those linear fixtures here. So if we go down in the instance properties, nothing there. It's in the type properties. Scheduling type properties is difficult here. So size would actually be a really telling parameter if we could get that across. But all of those HL2s were actually 4 feet in length. So that's the length that I assumed when I was tallying everything up. So then when we're back over here, you would just get those general counts. Let's see that HL type fixture, get the lengths of those, and then the quantities. And then depending on the EPDs that you're able to allocate, you would pull these together in one click to assign them to different EPDs. So if we look at Weimer Hall, we used several different light types. We've got a linear pendant, which was a 4-foot length, right? So you're dividing everything by 4 once you get those kind of total lengths for everything. A total of 730 for them. Circular fixtures are 277. We've got these down lights as well, 240 of them. These luminaires, let's see what that one looks like in particular. It looks like a different kind of linear fixture, 51. Some circular recess lighting, 206, and then floodlights. There was some stage lighting in Weimer Hall, so 217 of those. This is very similar to the other processes where once you've got the total quantities, units is the declared unit you'll generally want to use here. Finding the actual weight of a light fixture is not something we usually think about. Kim?
I can't remember, did this project not have any exterior lighting on it?
I can't remember if it did or if we chose to exclude it, thinking that that was outside of kind of like the site boundary. I believe we did include everything though, and maybe those lights were just included in this overall tallying that Alfred did. I would say calculate everything that you have available to you because it's all connected load electrically. So then we would go to details under A1 to A3 after you click results. Show numbers, drop this open, and you're able to see the kind of discrete GWP against each lighting type. You would tally that all up, total of 77,424, and then you can put that into the data entry template. But depending on the number of light fixture types you have, this could be really easy or it could be kind of challenging to just get everything tallied up in terms of total lengths of fixtures. But thinking about things like downlights, linear fixtures, like they generally fall under camps together. There's also a really nice sector-based EPD that was supposed to be coming out. I think it may be out already that WP was working on with Green Light Alliance that had 5 base light types. So that would be another good way to scale these as well if you don't have the particular EPDs that you want in one click with manufactured EPDs. Any questions about light fixtures? All right, got Wyatt and Mirko presenting PV panels. Do you want to present from your screen, Wyatt?
Yeah, I can share my screen. Let's pull this up. Okay, can everyone see my screen?
Yeah.
Yes, great. Well, hi everybody. So PV panels, very similar to lighting fixtures and other types of takeoffs from an overall general process standpoint. So with PV panels, for the Weimer Hall example, there actually wasn't PV included, so some of your projects may have this, some may not. And depending on the kind of path your project took for designing, very similar to lighting, there might be multiple parties at play when it comes to the PV design. So you pretty commonly, this is delegated design in a lot of our projects. And so for some of the examples that I'm going to show, since there wasn't any in Weimer Hall, we don't actually have great Revit information on the PV panels, but I'll show you in general kind of how you would start that process. So very similar, identify if you have panels in the model at all. So this is an example from one of the case studies that we are working on, where there is very little information on PV panels, and there's just a generic family that's been provided. But very similar to other steps that we've gone through, you would create a Revit schedule, and really, ideally, you would have more information that covers the power capacity, the rated capacity of the panel, length and width fields, could potentially calculate an area. Very oftentimes, this is not the case. And since we just saw how to make a schedule, I won't go over that, but I will show an example of where you might find this information if it's not in Revit. So I would guess for a lot of people, most of the PV system quantities and takeoffs you're going to do are going to come more so from drawings or from project specifications. And so this is an example where a PV contractor was responsible for providing drawings on a project. And so you can see high-level diagram of what the PV array includes, so the PV panels themselves, but also the other balance of system components, so disconnects, inverters, transformers, etc. Important to note, for this, we are excluding a decent amount of the balance of system components. So we are excluding optimizers, we're excluding the PV wiring, electrical disconnects, combiner boxes, etc. So we're really just focused on the PV panels, the racking system for the panel, the inverters, and if there were pedestals for the racking system as well. So a lot of the EPDs for panels are based off of, or for PV components are based off an area or a capacity of the panel. So looking in the drawings, looking in this case is actually pretty easy. On the very cover, they kind of provide the rated capacity of the system. So this can kind of help you get a takeoff very quickly for the PV array. But they also might provide information on the type of panel, as well as the quantity of modules, the quantity of inverters, etc. So you can see you've got multiple canopy or multiple arrays with different number of modules in this case. And then very similarly, you would either find this in submittal information or as part of the contractor's supply package or part of your own design if this is being designed in-house by your electrical engineering team. You'll have the product specifications and spec data on what these products actually are. So for example, for this inverter, you can see, you can find the weight of that inverter that's listed. Similarly, for PV panels, it's pretty easy to typically find a weight as well as dimensions if you were trying to calculate the area fairly quickly. So that would be the information that you're kind of looking for. Mirko, I don't know if you want to speak real quickly to the types of products we're actually including in this.
Yeah, sure. Okay, so fencing in pink, you can see the outcome of the calculation we carried out. And particularly, all of this calculation obviously refer to the EPDs we have used in this assessment on the left-hand side. I think perhaps here what it is important to say is to always double check the functional unit of EPDs because they could differ from the results that we want to produce. So in this case, obviously, the results are mainly in meters squared and kilograms, whereas the EPD's functional units come with different references as well. I mean, of course, if you use one-click LCA, it is possible to convert units. If you don't use one-click LCA, and if you do something manual, obviously, all of these calculations should basically be carried out by the assessor. I think another important aspect is the service life. You can see on the right-hand side a couple of notes about service life. So particularly the service life in red that are affected by, that could affect obviously the product performance, for example, inverter and PV panels. the remaining two, subframe and pedestal, often, I mean, this kind of service life does not affect the performance of the item. So, you know, it could be more flexible just in case. However, if you have an electrical engineer on the team, obviously, you can ask better information, and perhaps, you know, you can replace the EPD's information with the electrical engineer preferences. Thank you.
Yeah, and I would say the functional units piece are a little bit tricky, just because a lot of the EPDs differ from what the inputs that are allowable in one-click LCA. So if you are using one-click, just something to keep an eye on. Most of them are going to be area-based, so square meter, square foot, and that's based off of the area of your particular panel or mounting system. But just keep in mind your specific panel in your project could have a very different mass or a very different area or size or rated power capacity than what was used in these EPDs. And so there's a potential that you would have to scale these or even potentially scale your areas that you input based off of your particular array. So if there's questions on that, there's some info in the guide, but if there's questions, we can go over it. I think that's it for PV panels. Pretty quick.
I will also say that in the service life, when we get to B4, we've adopted the table from 240p on the reference service life for each piece of equipment. And I think that it says panels are solar panels are like 20 years. I don't want to misquote the document, but I think it's 20 years, regardless of what they say. So that's how we end up scaling when we get to B4, unless you have a more project specific value to go with. So there are reference values that kind of normalize these for all of those pieces. You'd assume they don't get replaced together.
Yes.
All right. So next part is vertical transportation. Very fortunate because we have vertical transportation consultants in-house at VH, and there's a lot I didn't know about elevators or escalators before speaking to our VT consultant. Tim Russell is the person I was consulting for this. So with elevators in particular, you're generally going to have 3 different types of elevators, and this is all referenced within the guide. So I'll actually just bring up this portion of the guide. These couple of paragraphs are really key in terms of parsing out what type of elevator you have. So you want to consider a few different functional units of those elevators. First, the number of stories served, of course, the capacity, speed, and then the weight of the actual unit. Capacity is its lifting capacity of like number of humans that go inside versus the actual weight of the elevator. There are 3 different kinds of elevators generally. So low rise, 3 floors or less. Kim? You're muted if you are asking a question.
I don't want to derail you too much, but knowing that we have 3 airport projects in the pilot group, are we counting all kinds of people movers?
Moving walkways count too.
Yeah.
Yep.
Okay.
That's here.
Okay.
We didn't have an EPD that we referred to specifically, so you won't see one down here. But that was something that Corey asked a while ago as part of the DAR group. So maybe once you find that resource, Corey, Brian, anyone else is working on an airport, you could share that with the group. But that wasn't something that we were pursuing specifically as part of this study. We're just trying to get down the general differences between these types of equipment. So for elevators, we have 3 kinds. First being low rise, 3 floors or less. They don't have machine rooms associated with them. So you will not see an elevator machine room on the top. That's how you can tell that it's considered a low rise elevator. So that's just a hydraulic elevator, non-hydraulic traction. And then we've got the mid-rise elevators. So that's generally 4 to 20 floors. You have MRL there as well. And then there's the high-rise elevator, overhead traction, gearless, and that is 20 plus floors. So those are the general types of elevators that you will see. When you go into your architectural model generally. You will find these on the specialty equipment category. Again, in general, not 100% sure what every architect does, but if you tab over that object, even from your MEP model, you'll be able to see it in plan. You can generally see the number of cars there. You could see if there was a machine room. It should tell you a few different properties. So this says it's a 4,000-pound car. The travel height is 99 feet. A couple of other type properties here. Cab height and depth. So you can compare whatever information that's given to you to try to find, but it sounds like ThyssenKrupp has just 3 general kinds, and they have 3 EPDs, which is great to get them directly from the manufacturer. So being able to see those EPDs within the guide is really nice. So the capacity, the speed, the weight of the unit are all provided. You could also go look at the EPD itself, and then just seeing the kgCO2 for those elevators. And then the same thing for escalators. We provided some details on escalators. So for those, it's a vertical rise, the speed, system lifespan, cable maintenance frequency, and then the weight of the unit and passengers per day actually matters for escalators. So that's the, I guess, gist of how you would, you've got uses class 3 and 4 for escalators here. So I guess just go into your architectural model, figure out how many stories you're generally serving, if it has a machine room or not, and then you would know which of these EPDs to end up using. And we've got the reference to the EPD over here, so you could just copy that into one click to be able to use it within your project. Any other questions on vertical or horizontal transportation? Okay. That product actually ended up being the worst, the most carbon intensive. It was in the top 10. The elevators on Weimar Hall, when we did our uncertainty calculations, you figure out which product had the longest kind of like from A to C amount of embodied carbon. The elevators were up there. We also put the cable maintenance as one of the B2, B3 factors on those. So we'll talk about that later. But it was interesting that that ended up being the case. They also tend to be a lot of your budget on the project, so that makes sense.
I have a quick question.
Oh yeah, go ahead, Brian.
The machine rooms and all the extra equipment, is that calculated into it as well? Or is that not a part of it?
I assume that all of the gears and stuff that go on top of those traction elevators is accounted for as part of the weight of the overall unit. You can confirm within the specific EPDs, though, if that is a part of it. I assume that it is a part of it, though, but not like the room geometry itself.
Okay, thanks.
I had a question, but I think it's along lines with Ryan's. So it sounds like you're using it per unit, right? And just kind of assuming that the weight is comparable versus digging in and trying to figure out the weight of all of the equipment in the project.
Yeah, and you just count the number of cars.
Okay. Did you get a sense from your elevator expert or that those are pretty comparable? Like, does it change a lot? It doesn't.
No, he was like, there are 3 kinds of elevators, no more, no less. Like, that is pretty standard that you would have those. And if you think about it, as long as the kind of mechanism, like the motors and stuff, are the same for all of those 3 kinds, it's the cable distance that really is the differentiator. And like, that's not particularly carbon intensive.
Sure. Okay.
Maybe when you get to like super high rise buildings, something would adjust, like maybe have a specialty elevator. I have no idea. But it seemed like it was pretty hard and fast as a rule about which kind of elevator there was.
I guess super high rise, they just maybe double the number of elevators if they're doing like splitting which floors the elevators serve.
Yeah, I can think of an designed an 89-story building once, and they only had space for 2 elevators in the building overall. So like you have to be efficient with that space. You can't kind of like an office building where you carve out like you're going to go up 20 floors, you do the next 20. But yeah, I'm sure that's the very high-rise scenario. Maybe there's a specialty kind of elevator, but you can always consult with your project directly.
One more quick follow-up. Just the this is kind of, you know, I guess embodied, but operational, is that information embedded somewhere? I know, you know, like like destination dispatch is way more efficient than the older school elevators. Is that, have you seen that generically in EPDs or the information?
Not that I've come across, but I think in terms of the load requirement for elevators, that would be part of the B6 calculation that we would do for your project overall. So
Yeah.
look out for it there.
Okay. Okay. Thanks.
Okay. Yep, Gina.
Hi, Kaylee. Just a quick question with regards to the previous recordings of these calls. Are they saved somewhere?
They're on
As I
YouTube.
mentioned, they're all on YouTube. Okay.
Not
Perfect.
the Q&A sessions. We've only been posting because people feel free to ask their own questions in those sessions. But the regular sessions like this one will be posted to YouTube.
And the Q&A are not recorded, right?
They're recorded, but I didn't post them on YouTube. So you can come back and find them in the Teams chat if you need them.
Okay. Sounds good. Thank you so much.
All right.
Could you send the link again for the slides? You said they were on the drive.
Yes, those are all on the CLCA drive that was sent around.
I don't think I got that.
Okay, we can send a new link to everyone on that.
Thanks.
To the YouTube link in there as well. All right. Last thing we have to cover together is plumbing fixtures. So that's generally a category that exists within the architectural model as well. So we'll go through what that process looks like. So we've got some pretty descriptive instructions here on, again, how to create that schedule for yourself. But if we go to a 3D view, turn on just plumbing fixtures. Okay. You can see all of the plumbing fixtures that appear within the model. In terms of EPDs that we were able to find, it was really easy to find like Kohler, toilets, lavatories, faucets, urinals, all of that stuff was readily available to us. Had more difficulty finding things like drinking fountains and mop sinks. So we put those under exclusions. But in terms of general plumbing fixtures that would be used for bathrooms, they were pretty easy to find EPDs for. So we've included all of those in our inclusions list. So you would go to view, create a schedule here, schedules and quantities, but I'll show you the pre-baked one for this. So by adding in properties for family and type, and then count, coming over to filter, sorting, grouping, making sure if you want to that you itemize every instance. But in this case, what we were doing is actually using the count so that we had a number against each of those. So you can see here that we've got 8 ADA lavatories. We've got 2 nozzles there, faucets, but some of these are kitchen. So I would exclude the kitchen related items here and then focus more on like the toilets. There were no urinals on this project. And then I also counted the number of, so lavatories, faucets, and that was it on this particular project. So you can see the number of sinks here, 28. Then we used one click to find the number of EPDs we would use. So I'll come back here. Again, this project is reflective of Weimar Hall in terms of the results, not necessarily what I was showing up on the screen there. So if you look at plumbing fixtures, pretty easy because you're just doing it by number of units. You can see that I've been playing around with the kilograms. The nice part about using this tool is even when I put in the number, so it's 40 toilets, I quickly flick it to kilograms so that I can see how much they weigh and then put that in on my mass value in the data entry template. I would suggest that for all of these, that it's nice in here because OneClick always has a weight-based option for each of these, rather than you having to do that kind of scaling yourself. If you go under technical characteristics, you can see that each one weighs 3.2 kilograms. You just flick the units to kilograms quickly and you can see how much each of them weigh, and then just put that in. Weight is used for A4 transport, so getting those objects to site. And then also during B stage, you replace them. And then at C, when you dispose of them, you also need to know the weight. So weight's a really useful metric for us to kind of be able to pull on each time. But overall plumbing fixtures are simple category to evaluate overall.
Can
Any
you remind
questions?
us why, or tell us why you would go for, if it has it in unit, in like actual unit of toilet, why you'd want to convert it to mass again? Like I know that's
So-
just doing that conversion.
Yeah, you
but-
want to keep it under units when you do the like A1 to A3, just so that it makes sense to you, like add 28 toilets, 40 toilets.
yeah.
For you also in the data entry template, which I'll flash that up for everyone. If you look at how this is working, which I owe everyone a new version of this after we've gone through all the values with CLF.
Oh
but
yes, this one. Okay.
yeah, you need the mass here. So the really easy thing to do is just say, I had, in that toilet example, it was 1769 in terms of the kgCO2 for A1 to A3, but it was 940 kilograms of toilets overall. You need that because when you get into this calculation in particular, which is for A4, it's based on weight.
Okay. Is there somewhere in this that we can make comments to ourselves that it was like 28 toilets, or is it kind of, would that be redundant since we have our other?
Yeah. I mean, you can always do that as you're going along, just so that you have kind of notes on what the category is. If you
Okay,
want to
that
add
won't
a
mess it up.
column in there or something.
Yeah.
If you add it like between these two columns, that would be totally fine. It shouldn't
Okay.
mess up any of the calculations. Like I've been doing
Yeah.
a lot of that kind of tweaking back and forth, and it seems like it's fine. But yeah, I'd suggest making notes to yourself as you go along, kind of get all the quantity takeoffs, and especially since we're between like architecture and MEP now.
Yeah. Yeah. Okay. Thank you.
Yep. Dremel?
I just have a quick, on the OneClick, I don't know, I feel that it's really bad at converting, because when you convert from unit to kg, it's just like 3.2 kilogram per unit, it's like 128, but it's approximate. So as far as your quantity is, and it's not too big, it's fine. But if it's too big, then it's lots of variation from the exact amount. So just a quick thing on the OneClick, yeah, if you have faced the same issue, the big quantities.
Yeah, the other piece actually that is not a part of the guide right now, and you're reminding me, is that I should add in the flashometer device that goes behind it, because on Weimar Hall, we actually added that in addition. So maybe the porcelain bowl weighs that much if it's just wall hung, and then you've got the whole device and then the carrier behind it. So kind of calculating those separate devices and adding that up. That's what we did for Weimar Hall, just to get it to be functionally equivalent. So I'll add those kind of like diaphragm devices on there as well in the guide, just to make sure we're accounting for everything that we should.
Understood. Thank you.
Yeah, that does seem really light to just say that it's 3 kilograms. But you also wouldn't want to say, my cut sheet says it weighs 20 kilograms, but I'm still going to go with a by unit value. In that case, just do a kilogram based value for the toilet overall, so that it's the same on the A1 to A3 kilograms of mass and then kgCO2.
Yep.
That's what we've been doing as well for the lighting fixtures, where like, especially since the length isn't always in Revit, and so we're having to look that up anyhow. There's not always weight on the cut sheets, but sometimes, or the manufacturers have been pretty good at providing that information and then just putting it in as kilograms.
It's a good idea. If you can find weight, it's always the best way to go because it's the closest equivalence that you can find in a declare unit sense. And then also it functionally is very similar as a product. You know that the raw material is a roughly correct weight is always the best way to go. Harder to come by in some of these products.
I have a question on the PV. I'm curious if you guys looked at so one of on the units, the functional units, it seems like the EPDs, there's some that are based off a kilowatt hour, which then doesn't always show the underlying assumptions of that. So in OneClick, are you seeing any that are EPDs that are based off a kilowatt hour and then you're still able to convert it to kilograms within OneClick?
Well, it depends. It depends if one click of this kind of conversion factor. So, I mean, if you select the EPD in one click, and if you go to unit, and if you click on the drop-down menu, you are able to see if the conversion is possible or not. If it's not possible, obviously, you have to calculate any conversion manually.
I think we actually had to correct the EPD that was in OneClick because it was by watt peak and they had incorrectly scaled, right?
Yeah, that was for the inverter. Was your question related to the inverter or to the PV panel?
I was thinking the PV panel, but yeah, maybe it's both.
Yeah, so the inverter EPD that was available, the EPD itself, the functional unit, is in terms of AC power generated over the inverter's life cycle, and there's a a specific amount of energy that it's assuming for that life cycle. So OneClick only has it in terms of inputs of kilograms, and so they did a conversion based on the EPD functional unit specifications to get it to a kilogram input. So that does make it easier to scale, but it does also make it a little bit more convoluted as far as like how you got there.
Yeah. I was kind of avoiding the ones that did it per kilowatt hour and just finding ones that were based off of area. I'm not sure if they're doing it right.
Yeah, it looks like for PV panels, the way, and I don't know if this is how it's required to be calculated, but they're typically based off of watt peak, and then OneClick has just converted those EPDs to be based off of area in terms of input. So they're taking a watt peak per square meter and then converting that so you can just do a square meter input. But so I think for the most part, you'll be able to get away with using areas. I think the only challenge you might have is if there's an EPD that's vastly different from what your actual product selection is in terms of either mass, size, or power output. But I think for the most part, you should be able to find something close. They're all fairly common sizes and masses.
Any other questions? Luke?
I have a potentially dumb question, or I missed the first half, so apologies if you already answered or have covered it in the previous session. Just tell me to go watch the recording. But for the data for these, what are we taking as the kind of baseline material? For like steel or concrete, we have kind of the industry average EPDs. I imagine there's a number of like product EPDs for these particular ones. Are we averaging like EC3 data, or are we just picking one? Is there a table that we have like a lookup where we're like, start with this one and then yeah, what are we doing for that, Kaylee?
So welcome the chair of SE 2050, everyone, Luke Lombardi, who understandably would not have as much knowledge around MEP. So Luke, we've been covering that in terms of the EPDs that we referenced generally to just have a baseline, because like you said, there's not a ton of data available for MEP. EC3 only currently, I don't even want to count the number of MEP EPDs. They have not very many. So I know they're working on that, and that version's in beta in terms of like adding categories for MEP and thinking about the functional equivalents for each of those categories, but it's a lot of small parts. So what we've been using are any EPD that we can find in one click around these categories that is as close to being functionally equivalent as possible. So in some cases, we're using the one-click carbon, like carbon steel. Actually, we have Wheatland Tube. It's a US-based manufacturer for carbon steel, but we are using one-click's copper pipe value because we're doing the takeoffs based on kilogram by kilogram. So not as much thinking about like the thickness and the size and all of those bits. So our takeoff methodologies are usually based on mass for ducts, pipes, conduit, wire, and then scaling to those EPDs that we were able to find. The guide provides all of those baseline EPDs just as reference. If you find something better, you're very welcome to use that. And then we also, for the case study, actually performed uncertainty on every product just out of curiosity for ourselves. And when I just did the top 10, which is the RICS and 240 methodology, the weighting came out at 27.7, which is like not bad on a scale of 40 for uncertainty. So that calculation will also be a part of the guide under the case study. But yeah, every category kind of has a bit of like hit or miss on how close they are. Like the ThyssenKrupp elevators, that's probably what we specify on projects. There are only a couple of elevator manufacturers. But it depends on the product really in terms of how much was available. MEP equipment, you've got 50 different kinds of equipment and 5 EPDs to work with. So like our pump we were working with was really far off in terms of the weight that would specify, but we did it by weight. So using what we can and calculating uncertainty. So that's the general ethos that we've been.
Yeah, that sounds great. And I'll get up to speed. But I think these calls are great and these resources are also awesome. So kudos. Good job.
Thanks. We also have a YouTube channel that we've been posting all their previous videos too.
I just subscribed.
Nice.
Yeah, thanks.
Any other questions from the group before we sign off? Okay, so next week we've got fixtures Q&A, skipping a week, and then we're going to do geothermal, which Celine and Joel will be leading. Thanks so much for today, everyone. Thank you to Wyatt and Mirko for co-presenting.
Thank you.
Thanks, everyone.
Thanks, everybody.
Thank you.
Thanks, everybody. Bye.
Thank you.
Thanks,
Bye.
everyone.